Hi girls, so as you can see this one's about a thing called t-results. So t-results are primarily used as a way to turn trigonometry into polynomials. For the purpose of this, polynomials is just anything like a quadratic or a cubic or things like that. So it starts, as you can see on the screen now, by saying that t is tan theta on 2. So then I want to think about, well, what can I say about tan of theta? So I can say that tan of theta is tan of 2 lots of theta on 2. They're 2's, not z's. And then I can use my formulae from the other day, if you'll excuse the non-aligned equals signs. So this gives me tan theta on 2, which remember I can write as t, plus tan theta on 2, divided by 1 minus tan theta on 2 times tan theta on 2. So 1 on 1 minus t squared. So that tells me that tan of theta, in this language where t is tan of theta on 2, not half of tan theta, I'm dividing the angle by 2, and then I'm applying the function tan to it. So that gives me 2t on 1 minus t squared. So that's tan of theta. Now I'll go to a new slide, and we'll think about cos and sine. So often when I think about cos and sine, and I know the other one, you'll recall that I tend to like to draw a triangle. And if you'll excuse me, I'm currently looking for the right tool. So let's see. So here's going to be my triangle, which is not going to be big enough in fact, but that's okay. And that was meant to be a right angle. There we go. So if I call this angle here theta on 2. So what I just said was that tan, not theta on 2, not theta on 2. I want to call it theta. So what I just said was that tan theta, if t is tan theta on 2, is 2t divided by 1 minus t squared. Okay? And if you recall, t is tan theta on 2. So then I can use Pythagoras to work out this side. It is the square root of the sum of the other two sides squared. Okay. If I expand the things in the square root, so I get 4t squared plus 1 minus 2t squared plus t to the 4, which is the same as 1 plus 2t squared plus t to the 4, and that should look familiar. Pausing for effect. It's a perfect square, isn't it? So then this thing is 1 plus t squared. So I can chuck that. Oh, colour it on. Let's go red. Up here. So I know that this side here is now 1 plus t squared. So try and work out what cos theta and sin theta are in this language. Well, hopefully that's fairly obvious. I'm going to give myself some space up here. Probably should have paused while I did that, shouldn't I? Oh well. So I know that cos theta, so I know that cos theta is adjacent on hypotenuse, and I know that sin theta is opposite on hypotenuse. Okay. And that combined with the one we wrote on the other sheet, slide, whatever, they are the t-results. They're the ones you need to know, and you do need to basically commit these to memory. There's a few things going on there in terms of patterns and things. Like you'll notice the top of sine and the top of cos together form tan, and that the bottoms of sine and cos are the same. I use that as a memory tool for myself. So very briefly now, I'll just show you an example. So an example might be, if I know that tan theta over 2 to t, in other words, is 5/12 Sorry, no. Okay, I'm just going to let my error slide, and I'm going to start again, because I'm still not really good at editing this. And tan theta is 5/12. I want to make it slightly harder. And then the question is, what's sine theta? Sorry, what's sine of 2 theta? Okay, so normally when you see sine of 2 theta, you think, well, 2 sine theta cos theta. And in this circumstance, that would work, right? I could draw a right angle triangle and go 5, 12. You should all remember Pythagorean triads, 13. So that gives me sine of theta, it gives me cos of theta, and I'm done. That there is a problem with that. And the problem is that I don't really have enough information to tell you what if theta is in the third quadrant, okay? So then sine of 2 theta, if I use this format here, which has got a bit messy now, but cos theta is negative, sine theta is negative. Oh no, still positive, never mind. Okay, I want to do it a different way, basically. And I want to do it in terms of, if I let t be tan theta, rather than tan theta on 2, then this is like the double angle. Okay, so it works in the same fashion. So I can set the sine of 2 theta equals, what was it, 2 lots of t, so 2 lots of 5/12 on 1 plus 5/12, oh boy, squared. And you do a little bit of work, and it turns out that that is 120 divided by 169. Okay. Not a very good question. That's a pretty standard textbook question to get us started. We will think about some more algebraic problems like trig identities and things like that tomorrow. Okay. I hope this is a better video. I like it a bit better, but still learning the technicalities, as you can see. See you tomorrow.